Let's review a few things for Learning Check 6. So, in answering which of the following research questions could be addressed using ANOVA, which stands for Analysis of Variance. Remember that ANOVA is an F test versus a two-group t-test. So if you think of two-group t-test, TTT, so two groups for a t-test, you can look at some of these answers here, treatment A versus treatment B. So that's two treatments. So that would be a t-test. Does the average number of alcoholic drinks over the past 2 weeks vary among undergraduate students, graduate students, and professional students? So we're talking about an average here. So that's a mean, and we're looking at 1, 2, 3 groups. So that's more than 2 groups. Are there differences in the average cortisol levels among individuals with chronic fatigue syndrome, irritable bowel syndrome, and inflammatory bowel disease? 1 group, 2 groups, 3 groups. Does the rate of shingles vaccine vary among adults aged 45 to 54, 1 group, 55 to 64, 1 group, 65 plus 1 group? So remember, a t-test is 2 groups, TT, 2 groups, and an ANOVA is 3 or more groups. The next set of questions are looking at using the recoded, top-coded cholesterol. So the top-coded, just to remember, if you go to the NHANES and look at the distribution for LBXTC and do a distribution, you can see that we have several values that are above 500. So what we want to do is go to column and go to recode. And I'm going to do a formula column, and I'm going to call this total cholesterol 500. And I'm going to go back down to the bottom here and see that there are only 3 that are over 500 and change them to 500. And press recode. And you can see here now, if I do a distribution on total cholesterol 500, that my maximum value is now 500. So I have 7,624 observations from this data set that have a total cholesterol value. So if I go back to Learning Check 6, we now want to look at the variable labeled race Hispanic origin. And you realize that it needs to be recoded to combine the categories of Mexican American and other Hispanic. So the hint here is to check the variable names carefully, as many of them are similar. So if we go back to JUMP and look at the fact that we have 2 race ethnicity variables here. There's 2 race ethnicity variables. And the question would be is, how do I know which one? Well, if we go to our NHANES books and I click on demographics data, and I scroll down to 2013, which I have here, the 2013, and ask for the demo document here. I can look over here in the table of contents and see that here is the race Hispanic origin, and here is race Hispanic origin with non-Hispanic Asian. Our Canvas quiz here is specifically asking for the race Hispanic origin variable. So if I look again at my demos, that is RID race ethnicity 1. That's my race Hispanic variable. So let me pull my JUMP up here so that I can take a look at my race Hispanic variable. So that's this one. And that goes with RID, RETH. So I have Mexican American, other Hispanic, non-Hispanic white, non-Hispanic black, other race, and missing. So again, I'm going to want to do a recode, columns, and I want to do a recode. And I'm going to do race, ethnicity, Hispanic, and I want to make it a formula column. And so you can see here that I have 5 values. And if I go back to double check again with my Learning Check 6, I want to recode to combine the categories of Mexican American and other Hispanic. I want to combine Mexican American and other Hispanic. So I want to combine columns 1 and 2, or numbers 1 and 2, into a single value. So Mexican American plus OT Hispanic. So that's my 1, and I'm going to change it to a character. And my 2 is also going to be that same category. So if I can copy this, I can now go to paste that. My 3, I want to be non-Hispanic white. My 4, I want to be non-Hispanic black. And my 5 is simply other race. And so now I'm just going to press recode, and I can double check here that this has worked. And to double check that this has worked, I'm going to do an analyze, fit Y by X, and I'm going to put my new race, ethnicity, Hispanic into my X, and I'm going to put the variable, original variable into Y. And then you can see if I just look at the quantiles here that my Mexican American and other Hispanics are the 1s and 2s. My non-Hispanic blacks are my 4s, my non-Hispanic whites are my 3s, and my other race are my 5. You can also do this under a tables summary menu where I put my new variable here, and underneath it I put my old variable and press OK. And then I can see here that my Mexican American and other Hispanics are my 1s and 2s, and you can double check your the math that you have just to make sure that from your prior distributions that it added up. My non-Hispanic blacks, my non-Hispanic whites, and my other. Okay, so let me save this. And if I go back into my quiz, the question is, after completing this recode to create a new variable called race ethnicity, what statistical technique will you use in JUMP to ensure the recode has worked correctly? So you want to check that the 2 categories of the original variable were correctly combined into a single category. So it looks like you can actually use a fit Y by X here. You could check on distribution, but you can also check on fit Y by X. So how many categories? So once you've recoded it, answer how many categories there are. And now we want to look at whether the average total cholesterol differs by race, Hispanic origin in the population. So in our new variable, we want to know, does total cholesterol differ? So remember, if I go into our fit Y by X and I look at an X variable that is the red histogram, so it's a nominal, and a Y variable that is continuous, I'll get a one-way analysis of variance. A one-way analysis of variance. So race, ethnicity, total cholesterol, top coded 500, and we get our standard figure here, and we can ask for an ANOVA to get our results. So you can look at the null hypothesis. Then what is the alternative hypothesis that's associated with this? So we have 4 means. So the alternative, 4 means that are the same, and then the alternative would be that there's at least one different. Do we reject alpha for this, or excuse me, do we divide alpha in half for this hypothesis test? Since we have 4 means here, we are looking at equal to versus not equal to, or at least one not equal to in our alternative. And so there's no dividing of alpha here. Dividing alpha in half is only appropriate when you're looking at a one-sided test. So when you have 2 means, you're looking at a one-sided test. So if we go back into JUMP and look at our results here, you'd want to report your exact p-value, which is a p-value to 4 decimal places. Remember, for the null hypothesis, you choose that with a large p-value, and for an alternative hypothesis, you choose that when the p-value is less than alpha, and our alpha is generally a standard of 0.05. So we would then reject the null hypothesis here and determine that there's at least one mean difference. So get your p-value, and then you make your decision, and then fill in the appropriate values here from your JUMP. So we want to fill in the appropriate values here. So complete the following based on your F statistic. And then create a statement or pick one of the statements that generalizes the results. The next part here is going to ask you to use the data filter, whether the association between race, ethnicity, and total cholesterol varies by age. Specifically, they want to know whether there's an association between race, ethnicity, and total cholesterol among those ages 20 to 35. And red drop down and use a local data filter. The data filter will come up and we want to look at our age value and we're going to add that. And now I simply want to limit my filter to ages 20 to 35. So drag this over until you get it to stop on 35 years of age. And then bring this up to 20-year-olds. But you can see I can't quite get it to be exact, but it turns out you can type in the number that you want. So 35, and then go over and you can look and you can see how it's changed your results, right? So this follows the same interpretation as the prior part that we just walked through for plain race and ethnicity, but now it's conditioned on ages 20 to 35, and you would interpret this following the same guidelines. Here's my p-value. I need to report the means and standard deviations. I need to make a decision and then determine within that age group, what do the means look like, and then write a paragraph. So remember, in this Learning Check 6, for this first part, we've walked you down the path of what's the test, what's the null, what's the alternative, what's my p-value, what's my decision, what information do you need to include, and what's the conclusion. Now you're being asked to do all of that and report it in this paragraph. So go back through those same steps with the data filter results and write out what you've found and what your conclusion is. And then conduct the same analysis for age 65 and over. Age 65 and over. So remember, you need to go back to your data filter and you can clear it. And we go back to the regular results. And then you want it to be 65 and older. So again, you can just click here and do 65 and older, and report the same or similar results here. And then for a clustered bar graph to depict the differences, you're going to need to save your output to create a clustered bar graph for this situation. There's a lot of information out there on the internet for a clustered Excel spreadsheet. So you can Google that, or there is an Excel demo for creating graphs from jump results here in Module 6.